So as these fossils were being discovered in South Africa, there was great discussion as to how many species there were. As you saw, Broom was what we sometimes called a splitter, that he loved to split these all into different species. In fact, he may have been right, but we don't know for certain. As opposed to lumpers, who like to reduce the number of species, like putting Plesianthropus into Australopithecus. So at any rate, but they're clearly what we would call distinctive morphs. In other words, you can see very clearly here in the lateral views of these two skulls facing one another that there are differences. That the one on the left has that crest that you see peeking out at the top, right there. And that's a crest where the chewing muscles, if you clench, put your hands on the side of your head like this and clench your teeth, you'll feel muscles moving. Those are called temporalis muscles. And they come down and insert on the lower jaw, on the mandible. And they're one of your important chewing muscles. The other ones are, if you put your hands on the side of your face and clench your teeth, you'll feel the masseters. So the masseters and the temporalis, we'll revisit these a little bit later so you can see exactly what they look like. But those are the two major muscles of mastication, the temporalis and the masseter. And the crania are so small, these crania are like 400 or 500 cubic centimeters, and the muscles in Robustus have grown so large that there is an extra attachment area up there called a sagittal crest, and I'll talk about that a little bit more. Africanus, a good example here from Sterkfontein on the right, does not have a crest, okay? And you can see how heavily built the mandible from Swartkrans, which is Robustus, how heavily built that is, how strong the cheekbone is. This is a very thick cheekbone, which is where the masseter muscle arises from. And in Africanus, it's much thinner. So it looks like these are variations on a theme. There's an overall similarity in them, but it's the details that have urged us to look at fossils from Swartkrans and Chromedry as A. robustus, and fossils from Sterkfontein and Makapanskat, which we'll talk about shortly, and Tong as Africanus. So you see an overall difference. We don't want to go into too many details, but here are two different crania from Swartkrans. SK48 on the right is one of the best known classic robustus. And you can see a strong sagittal crest. And on the other specimen, you can also see a strong sagittal crest. And you see sort of a flat, kind of dish-shaped face. It's actually slightly dish-shaped. In other words, it's sunk in a little bit. And in lateral view, you can see that the cheekbones have moved so far forward here that you can't see the nasal bones. They're down in this little dish-shaped basin. And look how thick that cheekbone, or technically it's called a zygomatic arch, how thick and deep that is, because that is where the masseter muscles come off of and insert on the lower jaw or the mandible. And they only have about 530 cc's. Remember, modern humans are about 1,400, 1,500. So this is a third the size of your brain or my brain. So that's A. robustus. And the mandibles, the lower jaws, are powerfully built. They're very, very thick. They're deep, as you can see in the lateral view, and they are very thick from side to side. Ours are thin. These are 3 times as thick because of the intense stresses that it has to bear. The other thing is, and this reflects diet, is that you have cheek teeth, and I've talked about these. Cheek teeth are the premolars and the molars, right? And then you have the anterior teeth, which include the cornerstone of the mouth, as it's called, which is the canine, and then the incisors, the things that you use to slice through food, an apple, for example. So the ones in the front perform a cutting function. The ones in the back perform a grinding motion. They're grinding teeth, right? And the canine is a poking tooth, a piercing tooth. Well, if you compare the length, the surface area of all of these cheek teeth to the front teeth, in Robustus, they're huge. And the anterior teeth is so reduced that they're actually just squeezed in there. Whereas in Africanus, I said earlier, they're large and broader, and the back teeth are not disproportionately expanded. So we think that reflects an increasing specialization on some diet, probably, most likely, what you would use grinding for, a vegetarian diet. That there was an evolutionary trend from Africanus to Robustus that was an increased specialization and adaptation to a tough, coarse diet. Okay, so here are SK48, which I showed you in the side view, with its very large molars and very large, sort of bulbous, puffy-like premolars and canine, premolars and molars, kind of a flat face. This is SK52 and the mandible is SK23, but you can see here that this hides any nasal bones in lateral view, so you can't see them, and a very deep mandible with a very broad, what's called ascending ramus. The ascending ramus is what attaches the mandible to the bottom of the skull. And that is for the attachment of the temporalis muscles. That's why that's so large. So this whole architecture of Robustus is an adaptation to very extensive, heavy chewing, which has been interpreted as specialized in terms of vegetarians. Some of these specimens from Swartkrans, SK is the abbreviation for Swartkrans, STS was the abbreviation for Sterkfontein. They have this low sloping forehead, they have the dish-shaped face, they have a very deep, spell that for you, Z-Y-G-O-M-A-T-I-C, zygomatic arch, very deep zygomatic arch, or as we would call it colloquially, a cheekbone. And you see the very high sagittal crest just there. And these collectively, Australopithecus robustus, are sometimes called the robusts. You'll see that in the literature. Now, a number of years ago, a colleague of mine, Bob Brain, who was director of the Transvaal Museum, where many of these specimens are stored in the town of Pretoria, which is outside of Johannesburg. If you ever go to or live in South Africa, you should go to the Transvaal Museum and see some of the displays and maybe even get a peek at some of these original fossils. I first visited there in 1970. And a specimen, this cranium, part of a brain case, was found. It's the 54th fossil, hominin fossil to be found there, and it was called SK54. Well, what's peculiar is that within those two little yellow circles, you see little pieces of bone that are out of their normal position. Now, when you look at the brain case, there is an outer table, which is solid bone, and then inside that there's softer bone, and then inside that there's inner bone. And what has happened here is something has pierced that skull. And it was when the animal was alive, because these are fossilized in place. This isn't something that happened in the cave. This is something that happened when the animal was alive. And the distance between those two holes matches identically a leopard mandible, so that the two canines, read that, but a leopard. So that is a fossilized leopard mandible, and those two canines, the distance between the two canines in the lower jaw, fit that distance. And we know from observations of living leopards, when you go on safari, if you're fortunate enough to see a leopard, they're not always easy to find, that a leopard, after it makes its kill, they're so powerful that they can drag, in this case, the gazelle that they just killed up into the tree and stash it. So that scavengers like hyenas and vultures and jackals and so on can't take some of their meat away. It's a way for them to protect their kill. So it looks like leopards 2 million years ago had a propensity for some of these Australopithecus creatures. And that's what we see. And that would have been near the opening of the cave, and as that body decayed, those bones would fall into the cavern below. So if we look at Robustus and Africanus, you can see, I'm just showing you three characteristics here, that Robustus tends to be rounder in its shape. You can see it's a very different shape. You can see how the face is much flatter, whereas in Africanus and Robustus are all of these right here. Has a sagittal crest, no sagittal crest in Africanus. It has a very flat face, has a projecting face. And you can see that here also in Africanus, projecting face, very flat face, and especially when you look down on the top of it. So sagittal crest, no sagittal crest. Flat face, projecting face. Round brain case, more of an oval brain case. So you can see that overall they're very different. Now, how old are these sites? That's been a huge problem. Relative dating has been used, but not on the basis of stratigraphy, because we don't have that, right? On the basis of animals. Older fossils have a higher percentage of animals that are now extinct. Younger sites have a higher percentage of animals that are now living. And they've been ranked this way. We haven't talked about this site, Makapanskat. It contains Africanus. These sites down here contain, as you see, Africanus. These sites up here contain Robustus. We haven't talked about Drimulin, but there are nice, beautiful new fossils coming out of there. So relatively speaking, we can definitely say that Africanus is geologically older than Robustus. And it looks like, from analysis that we've published and undertaken, that Robustus was a descendant of Africanus. And Robustus lived probably between 1.5 and 2 million years ago. Africanus roughly between 2.3 and say 2.8 million years ago. So that's the rough chronology for these South African sites. I'm going to finish by introducing my good friend Ron Clark and his two assistants. Ron is a superb paleoanthropologist. He's worked extensively in East Africa and South Africa, where he worked with a number of distinguished colleagues. And he was going through some boxes in the museum, and he found a little bone that looked like it wasn't a bone from an antelope. It was classified as an antelope. Turned out that it was part of a hominin. And he was able to build a little foot around that with other bones. And then he found another piece, and it was freshly broken. And he sent his assistants into this cave, which was huge. I mean, it was a huge, huge cave with flashlights. And they found on the wall where that bone fit. Unbelievable. And it was named, because it had such a small foot, it was named Littlefoot. It's Australopithecus. And Ron went into there and with his tools started chipping away at the wall. And this led him to a complete skull of what looks like an Australopithecus, of course. Ron thinks it's a special new species, which he calls Australopithecus prometheus, I think. Maybe he's coming up with a new name. But it's like something that Raymond Dart founded another site that he called Prometheus because he thought it made fire, but it was actually staining of black manganese. But at any rate, here is this skull. It's still in occlusion. You've got the lower jaw, as you can see here, right here. That dish-shaped face, it looks sort of like a robustus, but I think it's probably an Africanus. It's not very dish-shaped. And he's still working on it. And he's also uncovered a complete hand. Interesting, that hand is curled like that, as if it was in a death grip or whatever. He's found the forearm bones. He's found, these are the forearm bones, and the hand is up here. And he's got pretty much a complete skeleton. Over 3 million years ago, he believes a creature fell into that cave. Before it decayed, it began to fossilize and be incorporated into the deposits and was preserved for over 3 million years. It is probably the oldest, most complete Australopithecus known from anywhere in the world. And you're going to enjoy, I hope, a short interview that I did with Ron talking about this incredible discovery.